Hello everyone, I've got a quick one for you today, which is the Chapter 1 walkthrough for Edexcel's Further Mechanics 1 textbook for further maths. Okay, our first question is from exercise 1b. We've got a particle P with mass 3m kilograms and particle Q with mass m kilograms. And the particles are moving in opposite directions along the same straight line on the smooth horizontal plane when they collide directly. Immediately before the collision, the speed of p is u1 meters per second and the speed of q is u2 meters per second. In the collision, the direction of motion of p is unchanged, so p still moves in that direction, and the direction of q is reversed, so now q is moving in the same direction as p. Immediately after the collision, the speed of p is 1/4 u1 and the speed of q is 1/2 u2, and then we're asked to show that u1 is equal to 2/3 u2. Okay, so here we're just going to use the principle of the conservation of momentum. So if we take one direction to be positive, let's say to the right to make things easier for us, then before the collision the total momentum is 3mu1 take away mu2, and that's equal to 3/4 mu1 plus 1/2 mu2 for after the collision. Then we can do a little bit of rearranging to get 9 quarters mu1, so that should be a subscript there. So yeah, 9/4 mu1 is equal to 3/2 mu2. Then you can cancel out the m's, multiply both sides by 4/9 to get u1 as the subject, so that's going to be 12 over 18 u2, and we can simplify that down to 2/3 u2 as required. And our next question is from exercise 1c. A particle of mass m kilograms moves with a constant velocity of ai plus bj meters per second. After being given an impulse, the particle then moves with a constant velocity of ci plus dj meters per second. So our initial velocity is going to be ai plus bj, and then the final velocity is ci plus dj. Given that the direction of the impulse makes an angle of 45 degrees above the direction of I, show that b plus c equals a plus d. So here we can use the equation for impulse in vector form. So the vector representing the impulse is going to be equal to the mass times the change in velocity, which is the vector v minus the vector u. So we have the impulse is the mass times the velocity, the final velocity, which is cd, minus the initial velocity, which is a b. Then we can combine these two vectors, so c minus a and d minus b. And now the last bit of information we need to use from the question is that the direction of the impulse makes an angle of 45 degrees above the direction of I. So that's the direction of I, going to the right there. And we're told that the direction of the impulse is 45 degrees above the direction of I. And that means we're going exactly northeast, which means that the components, the horizontal and the vertical components of the impulse are going to be equal. Because another way to think about it is tan of 45 degrees is 1. So we're going to be going an equal amount to the right as we are going up. And so that means that c minus a must be equal to d minus b. So if we add b to both sides, add a to both sides, b plus c equals a plus d as required. And finally, from mixed exercise 1, we've got a particle P of mass m kilograms moving at a speed of u meters per second when it collides head-on with a particle Q of mass km kilograms, also travelling at a speed of u meters per second. And so if they collide, that means Q must be moving in the opposite direction to Q for them to actually be able to collide. Okay, after the collision, the two particles move off together with a common speed of v meters per second. Show that k can be written as u minus v over u plus v, or u plus v over u minus v, and then explain how these expressions relate to these two things down here. Okay, so first of all, we know that they're going to be moving off together or coalescing at a common speed of v meters per second, but we don't know if it's going to be in the same direction as p, in that direction there, or if it's going in the opposite direction in the same direction as Q was initially. So it could be going either way, and we need to consider both options, and that's where these two different expressions for K come from. Okay. So let's say we take the to the right direction as positive. Then if we consider the momentum before and after, so if we do the blue case first, so before the collision we're going to have mu minus kmu is equal to, afterwards it's the whole mass m plus km moving at v to the right, so that's positive. Then we can do a little bit of algebra. We can expand the right hand side, and remember we're looking for an expression for k, so if we move all the terms with k to one side, so kmu plus kmv is equal to mu minus mv. Then we can cancel out the m's, and then factor out k from the left hand side to give us k equals u minus v over u plus v. So that is the first expression on the left there sorted. Now if we look at the other option, so this purple option where we have the two particles moving to the left after the collision. So it's going to be the exact same thing for before the collision. Then we're going to have a minus momentum afterwards. Okay, we can cancel out the m's again. And we have u minus ku being equal to minus v plus kv, sorry, minus kv. Then we can collect the k terms, so ku minus kv equals u plus v. Then factorize k out, divide by u minus v, gives us u plus v over u minus v, which is our second option. So that's the first part done. Then we need to explain how these expressions relate to, first of all, the relative size of u and v. Then if we think back to what the k actually represents, that's the mass of q, right? The mass of q is km kilograms, and masses have to be positive. So that means that u minus v and u plus v have to be positive. The fact that u plus v has to be positive doesn't tell us anything, because we know already that u and v must be positive. But u minus v being greater than 0 tells us that u must be greater than v, and that tells us the relative sizes of them. So that's us done for part A. And for part B, the subsequent motion of P and Q after the collision, well, we've just said here, if they move to the right afterwards, then we're going to have this blue expression for K. If they move to the left afterwards, then that's going to be this purple expression. And we shouldn't really use left and right because that's our own diagram. It could have been mirrored. So we need to say that for K being equal to u minus v over u plus v, we have to say that the motion of P is unchanged. So we can't just say left to right because not all diagrams will look the same. We have to be specific and say that it's going to be in the same direction as P was moving initially. And then we can say the motion of Q is reversed, and the motion of Q is reversed, and vice versa for the other one. For K equals u plus v over u minus v, the motion of P is reversed, and the motion of Q is unchanged. And that is the end of this challenge question walkthrough. Thank you for watching. I hope you found this video useful, and I hope to see you again soon.